Hi everyone, today we are starting 4.2, which is apply congruence in triangles. Which figure below do you think is congruent to figure A? Now let me scroll down so you can see which of the other figures, but we want to know which of these figures is congruent to figure A. Well, congruent means the same. So which figure here looks the same to angle or to letter A? B would be congruent, C would be congruent, and E would be congruent. If we look at D here, we notice that its little arms here are definitely longer than the arms in A. And if we look at F here, we definitely see that this is thicker than that part there. So the only ones that would be congruent would be B, C, and E. Well, what are congruent figures? Congruent figures are figures with the same shape and size. So these pumpkins here would be congruent. They are the same shape and the same size. These pumpkins down here would not be congruent. We have a baby pumpkin, a medium-sized pumpkin, and a large pumpkin. So they are different size. They are not congruent. So once again, congruent shapes have the same size and are the same shape, and not congruent, they are different sizes and shapes. Corresponding parts in congruent figures. If two figures are congruent, then any pair of corresponding parts are congruent. So we have two congruent triangles here. Triangle ABC and triangle FED. So let's list out all the corresponding parts. Let's start with the angles. We notice one tick mark at this angle and one tick mark at this angle here. One tick mark means that those measures are the same. So angle A is congruent to angle F. If we look at angle B, we have two tick marks here. Which angle would match up with angle B? It would be angle E. So angle B is congruent to angle E. And then thirdly, we have three tick marks here, three tick marks here, which means those angles are also congruent. So angle C is congruent to angle D. Now let's look at the sides. And once again, we want to look at the number of tick marks. So I see one tick mark here and one tick mark there, meaning that those line segments are congruent. So segment AB is the same length and congruent to segment FE. I have two tick marks here. So what segment would be congruent to segment AC? It would be segment FD, because we see two tick marks there. And finally, we have three tick marks here and three tick marks here, meaning those side lengths are congruent. So BC is congruent to ED. All right, so now I know that these two figures are congruent. DEFG is congruent to SPQR. I want to find the value of X and find the value of Y. All right, so to find the value of X is this side length here. I need to determine which side length is congruent to segment QR. And you actually can look at our original statement here. QR is the last two letters here. I can circle them. And if I look at the last two letters in this first section, I have FG. Those line segments then are congruent. And if you look at the picture, you can see that those are the same side lengths. So if they're congruent, I'm just going to set them equal to each other. So 2x minus 4 is equal to 12. I'm going to add 4 to each side. So 2x is equal to 16, which means x is equal to 8. All right, next I want to figure out what the value of y is. So y is this angle measure right here, which is angle Q. So if I go back up to my original statement here, Q is the third letter. Well, F is the third letter. So angle F and angle Q are congruent. And if I look at what angle F is equal to, F is equal to 68 and Q is equal to 6y plus x. Well, we do know what x is, right? X is equal to 8, so I can substitute x with 8. So 68 is equal to 6y plus 8. Subtract 8 from each side. 60 is equal to 6y, and so I end up with 10 is equal to y. So just a reminder that my congruent statement here at the beginning is what helped me determine which angles are congruent and which side lengths are congruent. Third angles theorem. If two angles of one triangle are congruent to two angles of the other triangle, then the third angles are also congruent. I'm going to scroll down here. So this is just saying if I know that angles B and E are congruent and angles A and D are congruent, C and F also must be congruent. And we know this because the angles all add up to 180. All right, so now let's find the measure of angle BDC. So BDC would be this large angle right here. Now, if I look at this figure, I technically have two triangles that kind of form together. So I'm actually going to redraw these triangles. And I am not an artist. Okay, so something like that. So these triangles, if I pull them apart, they would look like this, where this would be A, this is C, this would be D, and this is B, this would be D, and this is C. So technically, this is the angle that I'm trying to find. Looking here, I see that angle A is 45, and we have one tick mark. Well, if I look over here, I also see that I have a tick mark here, meaning angle B is also equal to 45. The amount of tick marks tell you which angles are congruent. If I look down here, I see two tiny tick marks and two tiny tick marks here. And it tells me that that's 30 degrees. So that means that this is 30 and this is 30. So now I'm trying to figure out what is this angle measure. Well, remember, when you add up a triangle's angles, it equals 180 degrees. So that means that 30 plus 45 plus, we'll call this x because that's the angle I'm looking for, is equal to 180. So we will add this up. So 75 plus x is equal to 180, which means x is equal to 105 degrees. So our measure here is equal to 105 degrees. In the diagram, what is the measure of angle DCN? By definition of congruence, what additional information is needed to know that triangle NDC is congruent to triangle NSR? All right, so let's look at what we know. We know this angle here, S, is 68 degrees in this triangle. Well, if I look at triangle DNC. I also noticed one tick mark. That means that angle D and angle S are congruent. They are the same measure. So this angle here is 68 degrees. I also see that this segment and this segment have tick marks, meaning that those side lengths are also congruent. I also have a pair of vertical angles here, and we know that vertical angles are congruent. Now we don't know what they are, but we do know that they are congruent. So lastly, if angle D and angle N are congruent to angle N and angle S, that means C and R have to also be the same measure. So if R is 75, C has to be 75 as well. So the measure of angle DCN is going to equal 75 degrees. Now, what other additional information do we need to know to prove that those triangles are congruent? What we would need to know is that these sides are congruent, so I will write that down. We would need to know that segment DC is congruent to segment SR. And we would also need to know that these side lengths are congruent. So that would be side length DN is congruent to side length SN. Properties of congruent triangles. The properties of congruence that are true for segments and angles are also true for triangles. So the reflexive property. If triangle ABC is congruent to triangle ABC. Symmetric property. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And finally, the transitive property. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. I would definitely write these in your notes. All right, and our last problem for this section, in the figure at the right, angle GOV is congruent to angle GOV is congruent to angle ANK, and we know that ray SO bisects angle GOV. Okay, so let's look at that here. So GOV is this angle, and ANK is this angle here. They are congruent, which means they're going to be the same measure. I'm also told that ray OS bisects angle GOV. Bisect means cut in half. So this angle is the same measure as that angle. All right, next, the measure of angle GOV is equal to 12x minus 2. So this entire angle here is 12x minus 2. I'll write it up here. And the measure of angle ANK is equal to 8x plus 34. We want to figure out what is the measure of angle 1. And angle 1 is this measure right here. All right, well, since these two large angles are congruent, I can set these two equations equal to each other. So 12x minus 2 is equal to 8x plus 34. So I'm going to solve for x by subtracting 8x from each side. So 4x minus 2 is equal to 34. Add 2, add 2. 4x is equal to 36, which means x is equal to 9. But remember, this isn't my answer. I'm trying to find the measure of angle 1. So to find the measure of angle 1, I need to figure out what is the entire measure of angle GOV. So I'm going to plug 9 into my equation here. So 12 times 9 minus 2, and this gives me 106 degrees. But once again, I'm not done because this entire angle here is equal to 106. I want to figure out what 1/2 of 106 is. So that means that the measure of angle 1 is 106 divided by 2, which is equal to 53. And now I'm done.